Okay, welcome to Unit 6. I'm recording a new video. I'm actually at my cabin in this week, and so it'll take me a bit to record this video. But here's a quick introduction to Unit 6. Let me share the screen here. So, Unit 6 covers transformers. This is a little bit of a tricky thing because the next class you probably take, CIS 6117, is focused all on text issues and will use transformers a fair amount and encodings and that sort of stuff. So, I need to introduce you to this topic, but again, we're not going to cover a lot of the textual stuff because, again, you have another course coming up on that here. So, if we look at the unit plan, we're trying to simplify things a little bit because we're working on the final project, or starting the final project. So the last part here is a link to the final project overview, which you should be working on this week here. And also the week 6 discussion is talking about your plans for the final project and sharing ideas for the final project. So all this stuff is final project stuff. We have some learning resources, an optional explore activity, and then this, what I consider kind of fun and light learning activity. So let's look at this here. So let's go to the learning resources first. So transformers have really taken over the world in the last 5 years. All large language models and stuff like that work with transformers there. So it's good to see a little background and see where these came from here. So um, this is just a little background on transformers and the early systems. This is the key paper that was written about transformers or introduced this whole transformer model. It was generated by a collaboration between Google AI and University of Toronto here. Tension is all you need is what it was titled, and this introduced to this transformer architecture, and you'll see this. This is the image that is shared all over, in every tutorial on the transformers and stuff. And I think this paper is somewhat accessible, so it's not a bad place to read compared to some other papers. But then there's 100 people walking you through it on the internet. So if you want to look at one of those, that's fine too. And then I just posted some information or some things about transformers, picking some sources that aren't the big ones, so but still really popular. I generally like IBM's introductions to this sort of stuff. It seems like a nice level of technical detail for this class. So this is their transformer model stuff here, and they again walk through each of the different descriptions of these models and what's done with them. This is text just taken right from IBM, and again, this ties directly into this paper on transformers here. NVIDIA has another thing on transformer models than AWS does. And again, AWS links to this actual picture with this stuff that you can walk through. So, and again, we talk a little bit about encodings, positional encodings, input embeddings and stuff, and that sort of stuff here too. These are all good to look at. But again, I'm not going to cover too much of this because, again, you'll be doing this in your next class more. So here's another one. I've liked this is just not from a published source or a corporate reviewed entity, but this person has some really nice visualization of how transformers work, which I've appreciated. So those are an introduction to transformers. Now, just be aware that the basic transformers have now been adapted a lot. We're now seeing like vision transformers where they take images and break them up into parts and try to replace convolutional neural networks or do something similar to convolutional neural networks or work with convolutional neural networks. There's a whole area of research there. There's real world models of transformers where they're robots being driven, where again we're not generating the next word, you're generating the next action of the robot. So there's lots of adaptations of the transformer architecture out there that we see today. but I think it's good to just be familiar with how the general transformer works here. So, um, okay, and then your unit discussion actually on the final project here. Um, your write-up, this is your transformers and large language models. Um, this just talks about, picking a transformer and go with some of the word embeddings. I think this is a good prereq to your next, like I say, the 6117 course where we're talking about embeddings, uh, and you're doing some testing out of large language models. I don't know if you've done this with large language models, but it's kind of fun to try these out. It's also interesting to see how good some of the and how bad different language models are. When you look at them, there's lots of differences here. It kind of also depends if you have paid versions. So as a CSS student, you are going using Google Gemini here. Oops, I haven't updated these numbers. Let me just stop and do that real quick. Mm. But yes, we're going through these models. Let me just delete here. I tried to update this model list for 2026 here. A couple things to note. Gemini is a CSS student. You have access to the Gemini thinking model, and most of these companies will charge for these. Like to get access to ChatGPT, the higher models, you need to be subscribed, uh, a paid subscriber, similar to these other ones. Also, I don't know if you've been following all the news this past week or so with Anthropic's Mythos and Fable, but they've been kind of banned by the U.S. government, and there's been a whole thing about those. So if you haven't seen that news, that's a good uh, thing to pay attention to. Okay, so besides, you want to pick one of these and just try it out. You can pick more than one if you want, but don't try not to choose too many of these. And you're going to try to do this. First, we're going to look at word embeddings. Then we're going to try common sense knowledge. And again, the idea is that you'll create a sample prompt and just try it out. These are just simple experiments to see how this does with different tasks. It's kind of just a fun and interesting thing to try. To do with these models to see how how good they are at different things. So just work on those and post and submit those stuff. So again, that's supposed to be just kind of a fun, light, easy homework that you can work on. It shouldn't take too much time, and then you can focus on your final project here. Um, Again, I wish we could spend more time on Transformers. There's more information here if you want to look at some of these optional stuff on Transformers. One thing I do recommend is the MIT's class. They post an updated course or video on from one of their classes, and their lectures are usually very good. So I really like these sorts of lectures from MIT for this here. Yep, so that wraps up. Try to keep this simple. And again, I'll have another video introducing the final project or going over that. You might want to watch that also.